Hello, class. We are now getting into our second lesson on waves. In the previous lesson, we focused a lot on the different types of waves as well as their parts. In this next lesson, we're going to continue to talk about parts of waves, but now we're going to look at how the parts are affected by changes in amplitude and pitch. So our learning target for this particular lesson is going to be number 2. I can explain how parts of a wave affect changes in amplitude and pitch. Let's first start off by talking about amplitude and what that is. Amplitude is related to the amount of energy that a wave carries. We have already established in our previous lesson that waves carry energy. When we're talking about amplitude, the amplitude tells us, well, how much energy is this wave actually carrying? A wave with a large amplitude is going to carry more energy than a wave with a small amplitude. Think about these questions below. Which wave do you think would have a larger amplitude? A light wave from a bright light bulb or from a dim light bulb? If you said bright light bulb, then you are correct. This light is much brighter, so it's going to carry a whole lot more energy. Therefore, it would have a larger amplitude. Which would have a larger amplitude, a loud sound wave or a soft sound wave? If you said loud sound wave would have a larger amplitude, you are correct again. That just basically means that that wave is going to be carrying more energy. Let's look at a couple of pictures. As you can see in these pictures, remember we talked in the previous lesson about how you can measure the amplitude of a particular wave. You start from the resting position and you go up to the crest, or you could measure in the opposite direction and go from this resting position line down to the trough. Well, this particular picture shows me here, if I compared it to the second picture, that this one is going to have a lower amplitude or has less energy because it has a lower amplitude. And then this one would be carrying more energy because it has a larger amplitude. So we can see here in these pictures, we can see how that part of the wave, which we call the amplitude, affects how much energy that wave is carrying. Now, let's talk about another characteristic of waves. In our previous lesson, we talked about wavelength. And here on this slide, we can just see a quick review of how you measure the wavelength on a particular wave, which is just basically when I go from one part of a wave to the identical part on the next wave, crest to crest, or if I were measuring from the bottom, it could be trough to trough. On a compressional wave, you do the same thing. You can go from compression to the next compression or from rarefaction to rarefaction. Now you're probably thinking, well, we've already talked about wavelength. How does this relate to where we're going with this? Well, let's look at our next characteristic and we're going to see how these two things are related. Frequency. Frequency is the number of wavelengths that pass a given point in 1 second. So by looking at the wavelength of a wave, we can determine the frequency of that particular wave. A wave with a low frequency is going to have a long wavelength. A wave with a high frequency will have a short wavelength. Frequency and wavelength have what we call an inverse relationship. Whatever one does, the other one is going to do the opposite. Let's look at a couple of pictures. You can see here, this is a low frequency. And if I were to take my ruler and measure the wavelength here, you could see that this is a pretty long wavelength compared to this one. This one is a higher frequency because my wavelength is much shorter. And I want you to think about that for just a moment. If I have the waves stretched out further from each other, which means I have a longer wavelength, that means I'm not going to have that many waves passing a point in 1 second. But if they're closer together, that means I would have more waves that would go by in that time frame, however long I'm measuring it for. So the more you look at examples of this, it's going to kind of start to, it'll start to make sense to you, this inverse relationship that frequency and wavelength have. Let's look at another picture. Okay? This one kind of shows you, on this particular picture, we can see long wavelength, low frequency. Short wavelength, high frequency. Okay? Look at the waves below. Which wave has a higher frequency? If you said the bottom wave, you are correct. Why does it have a higher frequency? Because it has a shorter wavelength. If I were to measure the wavelength here, it's much shorter than the wavelength between these two waves. This is much longer. Okay? So now we've kind of established the relationship between amplitude and energy. And we've also talked about the relationship between frequency and wavelength. Pitch is our final characteristic that we will discuss. Pitch is actually a characteristic of a sound wave, which we're going to have a separate lesson on sound a little bit later on down the road. But I want to talk about pitch now because it is mentioned in our standard. And pitch is very closely related to the wavelength as well. Actually, I always tell students that pitch and frequency are like identical twins because whatever one is doing or looks like, the other one is going to look exactly the same. Um, so if I'm looking at a particular wave and I've already established that that wave has a high frequency, then I automatically know that it's going to have a high pitch, and then vice versa. If I have a low frequency, I'm going to have a low pitch. And the pitch is just how high or low that a sound is. Those of us that are familiar with instruments and music and things like that, we probably are very familiar with the word pitch. Look at the waves in the picture here. This would be high pitch because it has a high frequency and a short wavelength. This would be low frequency, low pitch, and this one has a long wavelength. So here we can kind of look at the relationship that pitch, frequency, and wavelength kind of have with each other. And hopefully what we were able to see over these slides is how the parts of the wave kind of determine the type of characteristic that a wave is going to have. That concludes our lesson on characteristics of waves. Make sure that your graphic organizer is completed with pictures. Thank you.